Assalamu alaikum everyone. I hope you guys are doing great. In this video, we are going to discuss the logarithmic function. We are just going to, revise the old contents and then we'll talk about the new unit. Okay. All right. So far we know what exactly is the logarithmic function. Logarithmic function is just log. It has a base and this is how we write it down. This is the logarithmic function. How and where exactly it is used, so let's talk about it now. Okay, so whenever you have y equals b power x or something of that type, you can always write that as a logarithmic equation. How? This power would come here, this is your base, and this is where we write down base for log equation, and then y is going to come here directly. So for example, if let's say if you have 9 equals 3 squared, I can write this thing as this is the power. So this power would come here, 2 equals, this is the base, this would become log 3 and this 9 would come here. So this was a quick idea about what we have been discussing in case of the log function. Then we discussed two special cases. Whenever you would have 1 here, it would be 0, and whenever these two things are same, it's just 1, and this thing would basically come over here. So this would give you n log bb, and I've just told you this thing is 1, that is why it would give you n. Okay, anyways, then we discuss some questions. If you guys are interested in detailed contents, you can just watch the old videos. Then we discuss some logarithmic properties, that when we have two numbers and when we are multiplying them, we can write that as a plus sign. When you are dividing that thing, you can write it as a minus sign. Again, this n would basically come here, we can write it over here, and so on and so forth. We discuss some properties and some questions as well. Okay, all right, then we had a past paper question, we were able to do that. Now let's talk about this new content that we need to discuss today. It is basically the 5th unit of the 2nd chapter, that's algebra. So it's 2.5 and it says using logs to reduce equations to linear form. Okay, this is what we need to discuss. Let me just underline this and then you will get a better idea about it. Now, the first thing is, what exactly is the linear form? We know when we talk about linear, the word linear basically makes us think about the straight line. And if I talk about a linear equation, or if I talk about the equation of a straight line, it's something of this type: y equals mx plus c. So this is basically a linear equation or the equation of a straight line. And now you will see we will use log to convert equations to linear form. Okay, all right. Okay, things would get better once we talk about some questions. Let's discuss. Question number 1. Okay, so it says, for the following linear equations involving logs, find the relationship between unknown variables, giving your answer in a form not involving logs. Okay, all right, so find the relationship between variables giving your answer in a form not involving logs. All right, okay. The first one is log 10y equals 2 plus 3 log 10x. Okay, now what exactly is the statement saying? It says find the relationship between variables. What are the variables x and y? Giving your answer in a form that does not involve logs. Okay, so we need to reduce this equation to another form. And finally, since it would be another form, so it would not be having logs, and you would be able to see the relationship between x and y very, very clearly. Okay. All right. So first of all, we need to have log with, in order to get rid of log, you need to have log with every term. Okay. So let's talk about the solution. Okay. We have log base 10 y equals 2. Now I can write 2 multiplied by 1. And instead of writing 1, I can write that thing in terms of log as log. The base is 10, so I'll write down 10 here, and I know that this is basically equivalent to 1. So I can write it certainly. Plus 3 log base 10 x. Now I need to simplify all of this. I'll take this 2 over here. I'll take this 3 over here. And this would give me log base 10y equals log 10 squared plus log base 10 x to the power 3. This would become log base 10y equals log base 10 100 plus log base 10 x cubed. Now let's simplify both the left and right sides of the equation. What can I see? I can clearly see that on the left side, things are simplified. But if I talk about the right side, I have two log expressions. I can write it as one by looking at this plus sign. So whenever we have plus between two logs, I can write it as one log and base would be same, and I will be multiplying these two numbers. So this is what I am going to get. And finally, we don't actually cancel log with log, like that looks very foolish. But since this thing and this thing is same, and we have an equal to sign, this implies that this and this would also be same. So I can write it as y equals 100x cubed as the answer. So are we done with the question? Yes. Now I can clearly see that y is 100 times x cubed. The relationship between y and x is there, and I do not have log in my final equation. So I have basically used log to convert the logarithmic equation into an other type. This is not certainly linear equation like we have x cubed, it's a cubic equation, but the idea is similar. Okay, the idea is similar. All right, okay, let's talk about another example for this one, just so things get clear. I would want all of you to participate with me. Acha, if I talk about question number 1 part B, it is log base 10 a, and it is equal to log base 10 pi, and that is then we have plus 2 log 10 r. What was the question? The question was to find the relationship between the variable, that's the area, and its radius, and by using logs. Again, you need to make sure that for the final answer you do not have a log. So first of all, I have this 2 as coefficient. I can certainly write it as power of r. So this would become log base 10 a equals log base 10 pi plus log base 10 r squared. Okay, this is what I have. And it's a plus sign. We have two logs with the same base. According to the property, what do we know? I can write this thing as one log. So this would remain as it is. And on the other side, I can write it as log 10 pi multiplied by r squared. Again, the idea is same. We have two logs with same basis. So the logs are equal. This is also equal to each other. What does this imply? This implies that this thing is equal to this thing basically. So this implies that area is equal to pi r squared. We know that this is the answer. And in the answer, we do not have log. So this is correct. All right, this was the second question. And in case of any questions, any queries, any difficulties, please feel free to ask me. And if you are, if you were interested in proper live classes, then you can use the link in description to get yourselves enrolled for the live classes. Okay, all right. Let's talk about the third part of the first question that says log base 10 y equals 0.3 plus 0.7x. All right. Now again, the question is same. The idea is same. You need to just find the relationship between the variables and you need to get rid of the log. For that, we need to have log with every term. We do not have log here. We do not have log here. I'll add log term here. I'll add log term here. And I know that a log term that is equivalent to 1 would be this one, right? So I can easily just add this. So log base 10y is equal to 0.3 log base 10 plus 0.7x multiplied by 1. And instead of writing down 1, I'm writing it down in terms of log. So now I can just simplify this. I'll take this thing and I'll write it as power over here. I'll take this entire thing and I'll write it as power over here. And I am going to get log base 10 y equals log base 10 power 0.3 plus log base 10 power 0.7x. Now we have a plus sign. The left side would be log base 10y. It would be log base 10 power 0.3 and it would be multiplied by 10 power 0.7x. All right, okay. And finally, we can just simplify this entire thing. And this is going to give you, we have two logs with the same basis. So I can directly just equate this. And this would give me y equals 10 power 0.3 multiplied by 10 power 0.7x. What you can do is just simplify this. So we need to find what is 10 power 0.3, and that is y equals 1.995 and then 10 power 0.7. So that is going to be 5.012 power x. Okay, so this is going to be the final answer for this question. All right, okay, let's talk about the next question. Before that, let's quickly revise this. What happened here? Again, we were supposed to convert this logarithmic equation to an equation that did not include log in it. So for that, I had to add log with every term. After adding log with every term, I was able to just get rid of log. And yeah, that is it. So we are continuously, repeatedly using the same properties, and this is going to be the answer. Okay. The next one is basically a past paper question. Let's talk about that. Okay. All right. It says the variables x and y satisfy the equation. I'm writing down the equation directly. It's 5y equals 3 power 2x plus 1. By taking logs, show that the graph of y against x is a straight line and find the exact values of the gradient and the intercept. Okay, this is the equation. Show that the graph of y against x is a straight line and find the exact values of the gradient and the intercept. Okay. All right. So let's simplify this. Okay. What was basically the idea behind this question? That you need to show that the graph of y against x is a straight line. Now, this basically means that this is going to be a linear equation. When we will use logs in order to reduce this equation, this would turn out to be a linear equation. And then you need to find the gradient and the intercept. So let's talk about this question in detail. Okay. I have 5 power y equals 3 power 2x plus 1. And I've been told that I need to use log. So I'll take log on both sides. Log 5 power y equals log 3 power 2x plus 1. Now this is the power and this is the power, and I can write down these powers as a different way. So this would become y into log 5 and this would become 2x plus 1 into log 3. Okay. Next, y log 5. I'll multiply this 2x with this log 3 and this would give me 2x log 3 plus log 3. And finally, I am going to write it down this way. It's y equals 2 log 3 divided by log 5. And then I had this x over here. Then we have plus log 3. And then since we divided this log 5 on the right side, so this would come over here as well. Okay. Now the next part of the question was we had to find the exact values of the gradient and the intercept. So when the examiner would say exact value, you are not supposed to simplify that or do anything about it. We know that it's y equals mx plus c. The coefficient of x is basically the gradient and the constant term is basically the intercept. So using this information, I can write this thing as m is equal to 2 log 3 divided by log 5, and the intercept is log 3 divided by log 5. So this is going to be the answer. Okay. Let's quickly go through this question and then things would make sense. Here we had an equation, this you can call it an exponential equation because everything was written in the power of the number. And it said show that the graph of y against x is a straight line, meant that you need to prove that this can basically be reduced to a linear equation, that is y equals mx plus c. And then you had to write down the exact values of the intercept and the gradient. Okay. The question clearly had this thing that you were supposed to use logs. So I took log on both sides and I've used some basic log properties. I just took log 5 on the other side and this gave me y equals mx plus c type of a thing. So m was 2 log 3 by log 5 and c was log 3 by log 5. And then these were basically the gradient and the intercept of this line or this equation, right? So this is how exactly we are going to solve these questions. Okay, now obviously the question could be of any type. It could be of any type. You would be given with a scenario and you'll have to play with it accordingly. Let me just write down one last property just so everything is complete for this unit. Okay. Exponential growth or decay. Let's talk about this now. So we know that y is equal to AB power t can be written as log y equals log a b power t, and then I can write it as log a plus log b power t, and I can finally write it as log a plus t into log b. Okay. The graph of log y against t has intercept log a and gradient log b. Yes, that makes sense. And then we have the power rule and it says y equals axn log y equals log a plus n log x, right? This is what we have exactly discussed. And again, the graph of log y against log x has an intercept log a and gradient log n. So this is basically the idea behind this concept that we have just discussed. Okay, this was just about writing it down formally, but the examples and everything, things would make more sense once you understand this past paper question and this example which had 3 parts, because this is where exactly we've applied the knowledge. So by now we have been discussing the logarithmic function. Then we have discussed some properties, and time and again, we are using these properties to solve different questions. Okay. So yes. In case of any query, anything, you can just use the link in description to get yourselves enrolled for our live classes, or you can just comment in the comment section. I'll try answering you as soon as possible. Okay. All right. So take care, all of you, and have a good day. Allah Hafiz.